Well, welcome to our lesson here on segments and distance. We're going to first define a line segment. And so a line segment is a group of points that consists of two endpoints. That's important. And all the points between the endpoints. Now, before we get too far into the lesson, let me just tell you that this note sheet here is located in the description. So if you want to download a copy and be working it out with me as we're moving along, that would be great. Just look in the description there and you can download your copy. Um, I provide the note sheet because I've got diagrams and things like that. So that'll be helpful for you. Now, to measure the length of a segment, you can use a number line to find the distance between the two endpoints. Okay. So if you want to find the distance on a number line where A and B are the endpoints, then you're just going to subtract B minus A. And I'm going to show you how to do that. If we want to find the distance between -2 and 6 on a number line, and let's just visually, wrap our brains around what that looks like. So I've got -2, and I'll just number them a little bit here so we can see them. Now, our formula says we just subtract the 6 minus the -2. Now, I'm making a big deal out of that because when we have minus a negative, we have to change that to plus by changing the sign of the next number. So you can see that my distance here would be 8, but let's count it visually just to make sure, right? So I've got 1, 2, 3, 4, 5, 6, 7, 8. And our formula does work here. Now, I do it visually so you can see that, but I want to get to where I can use the formula because what if these 2 points are really far away from each other? I mean, that's the benefit of using a formula. So let's look at example 2. I've got a number line drawn and I want to find the distance of PQ. Now, let's think about that. I've got Q is at -2, and P, look at that, it's between -3 and -4, so it's -3.5. Okay. Again, making a big deal out of that minus a negative. I'm going to change this to plus a positive. Now, remember, when signs are different, we subtract these two and we take the sign of the bigger number. So if I subtract 3.5 and 2, I get 1.5. And I take the sign of the bigger one, which the 3.5 is bigger and it's positive. So I get 1.5. Or you could have said that as 3/2. Either one would have been okay here. Okay, let's look at QR now. Q to R. So we're going to take R looks to be between 2 and 3. So it's at 2.5. 2.5 minus Q, and Q is at -2. So again, we've got that minus a negative going on. So now we're going to add, which gives me 4.5 or 9/2. And again, looking at it either way here. Okay, let's do PR, find the distance PR. So R is at 2.5 and P is at -3.5. And so I've got to do plus there. And so that gives me 5 wholes and 2/2. So 5 wholes and 2/2 is 6 wholes. So the segment PR would have a length of 6 there. All right. So remember, when we want to find the distance on a number line, we do the subtract the endpoints, being really careful with that minus a negative piece. Okay, let's look then. What happens if we want to find the distance on a coordinate plane? Something that might look like this. So then we have to use the distance formula. And this distance formula tells us that we take the square root and we subtract the x's and we square it. And then we subtract the y's and we square that difference, and we add it. Okay, now this x2 and x1 piece, that might be familiar when maybe you looked at slope. That's very common in the slope formula. Just means the second x and the second y. The second x and the first x, the second y, the first y. So if I look at example 3 here, my first x is 2. My first y is -1. My second x is -2. My second y is -1. So if I follow my distance formula here, got a big square root, right? I'm going to subtract the x's. So x2 is -2 minus x1 is 2. And being very careful with my signs in there. And then plus, then I do the same thing with the y's. y2 is -1 minus -1. All right, so I've got all of the substitutions made. Now I just work underneath this square root. So in this first parentheses, -2 minus 2 gives me -4. -1 minus -1, we'll change that to plus plus. So now I've got -1 plus 1, that's 0. And now I've got -4 to the second is 16. And then the square root of 16 is 4. So my distance here between these 2 points is 4. Okay, let's look at example 4. Now, in example 4, we're going to have to read these points, these coordinates, from their graph. So A is at 2, and then 1, 2, down 3, so -3. And B is at 1, 2, 3, 4 over, and 1, 2, 3, 4, 5 up. Okay, so I had to read the coordinates from my graph in order to be able to, now I can identify this is x1, this is y1, this is x2, this is y2. Okay, so let's find the distance. Okay, so we'll do the x's first. So x2 is 4 minus x1 is 2, and we square that. And then y2 is 5 minus -3, and we square that. Let me take care of this minus minus piece. Makes it a little simpler for us. And so we work under the square root now. 4 minus 2 is 2. And 5 plus 3 is 8. Okay, order of operations says to do those exponents first. So 2 to the second is 4. And 8 to the second is 64. And now I've got the square root of 68. Now, if we want to simplify, and I'll be honest with you, most of the time we do, I come over here and do a little factor tree. I ask myself, okay, what multiplies to give me 68? Well, that would be 2 and 34. And I did the 2 because the 68's even. Makes it real easy to pick out that one. And I know 2 is a prime number, so I circle it. Then I come with the 34 and I say, okay, what 2 numbers will multiply to give me 34? That's 2 and 17, and both of those are prime. Now, what do you do with that? Well, you see I have a pair of 2's there. That means that I can write a 2 to represent the pair on the outside of the square root. But the 17's by itself, it has to stay underneath the square root. So my distance is 2 square root of 17 here. I really like using the factor trees because it makes it kind of simple to see those pairs. Okay, let's keep going. We're doing great. Looking at all the different ways we can find the distance. Now, in example 2, back when we did the number line piece, I'm going to bring that back here so we can look at it. Back in example number 2, you remember that the 1.5 plus the 4.5 equals 6. So notice that we actually added PQ plus QR to get PR, because we added the 1.5 and the 4.5 and we got 6. That leads us to the segment addition postulate. Now the segment addition postulate says if Q is between P and R, then we can always add PQ plus QR to get PR. So look at example 5 here then. If B is between A and C, and friends, I'm going to tell you, I draw a picture of this, just a little sketch. And I just say, okay, B is between A and C, because if I can see it, I stand a better chance at putting it together. If AB is 4, and then I label that, and BC is 5, then what it wants to know is what is AC. Well, when I draw a picture, I can easily see that. I should just add 4 and 5 to get that AC here is 9. Again, when I draw a picture of it, it makes it a little bit clearer to me. Okay. So look at 6. If AB is X, BC is X plus 6, and AC is 24. Okay. So let's draw that picture again so I can label it now with these pieces of information. So A, B, B, C. Okay. So AB is X and BC is X plus 6. And then AC, all of this is 24. Okay, so let's write an equation. I'm going to say, okay, AB, which is X, plus BC, which is X plus 6, has to equal the whole thing, which is 24. And now we get to solve. So X plus X is 2X plus 6 equals 24. Now we'll subtract 6 from both sides, so that I get 2x equals 18. And if you divide by 2 on both sides, you get that x is 9. Now, which answer is this? Well, it's x, so that's AB. AB is x, that's 9. And if x is 9, then BC is 9 plus 6, which would be 15. So the segment addition postulate here lets me write the equation to then solve for the pieces that I don't know. Let's do one more here. If LM, or find LM, if L is between N and M. Okay, so let's draw that. Again, when I draw it, makes it a little bit easier for myself. I got N and M and L is between. Okay. NL is 6x minus 5, and LM is 2x plus 3, and NM, the whole thing, 3x plus 13. Okay, so let's set up that equation first of all. We're going to do NL plus LM equals NM. Okay, so NL, 6x minus 5, LM, 2x plus 3, and that equals NM, which is 3x plus 13. Okay. Now, let's solve. So on here on the left, I got like terms. So 6x and 2x is 8x. Minus 5 plus 3 is minus 2. And now we got to get all the x's on one side. So I'll subtract this 3x here. And that gives me 5x minus 2 equals 13. Let me go ahead and add the 2 to both sides. That gives me 5x equals 15. And then if we divide both sides by 5, you can see that x is 3. Be real careful. X equals 3 is not the answer. Remember what the question asked. Find LM. So LM is 2x plus 3. And we just found that x is 3. So we substitute 3 in for x. 2 times 3 is 6. LM is 9 here. Okay, so that's how we use our segment addition postulate to help us find one of the missing sides. I hope this lesson was super helpful with our distance, whether on a number line or on a coordinate plane. Also with the segment addition postulate. If you have more questions or you want to see more topics like this, feel free to like and subscribe. Be sure and leave me a comment if you have any questions. I'd be happy to help in any way that I can. Bye for now.